Hi, good day to all. I'm Raju Goyal, PhD scholar at Sarda University. My co-author, Mr. Dr. N.V. Singh, Dr. V.K. Verma. Today, I'm going to discuss about the effect of the nanosilica on the property of the composite cement. As we all know that cement industry is known for the high CO2 emission, which is impacting the environment. We can see that 7% of the CO2 was emitted by the cement industry in 2021. We all know that about India is producing about 250 million tons of waste material from the thermal power plants and the steel industry, which is expected to be doubled by 2030. 9% greenhouse gases can be abated by using the waste material from the different industries. And this also provide the clean environment for our society. If we see that compared to the OPC, PSC is the one of the material which can reduce up to 70% CO2 footprint into the cement. If we see here, the OPC is much used into our cement industry or construction industry, whereas the composite cements are not much taken the leap in the last few years. Other than the CO2 emission of our composite cements, there's a few advantages and disadvantages. Advantages are they are very aggressive for the environment, resistance, and low heat of hydration, low alkali reactions, and providing the ultimate strength of the cement and concrete very high, and changes the rheology property of the concrete. However, there is a few disadvantages. They delay the initial and final setting time. They also delay the strength development in the concrete as well as the cement, and later strength is also developed significantly lower some cases. In the hydration process, this is the typical cement hydration process is shown here, which is have the impact of the temperature, amount of water, fineness, and the chemical compositions and mineral phases developed during the hydration process. So we see that here in this hydration process of the cement, when the water added to the cement, the calcium hydroxide are produced, which can be used by the pozzolanic material to develop the additional CHS and CH formation, which can provide the additional property and additional strength to the cement. Here we are using the nanosilica, which has almost 20 nanometer particle size and very amorphous silica. And the two types of cement we are comparing here is the OPC and composite cement, which is the mix of the fly ash and the slag. Here we see that in the ICC study shows that as we increase the composition or addition of the nanosilica, the heat is shifting toward the left-hand side. It means the acceleration of the hydration process takes place. Here also we had done the test on the TGDTA, which also shows that the available calcium hydroxide from the cement can be used by the nanosilica and develop the additional phases which can improve the performance of the cement. When we see that setting time impact of this nanomaterials, as we increase the doses of the nanomaterials, setting time drastically reduces in initial and final setting time both. Here we can say that the compressive strength of the cement by using the 3% of the nanosilica can be almost equal to the OPC performance. So it means the nanosilica can offset the adverse effect of the waste material, which is the setting time, and the strength can be controlled by adding the nanosilica. And here, so we say that this is the material, waste material usage can reduce the emission of the CO2 footprint into the cement industry. So it's improved the circular economy. And using the nanomaterials can adverse effect can be offset and increase the usage of the composite cement into the construction industries. And this also shows very high durability, workability, and concrete, all the sustainable concrete can be produced. Cement construction industries also can play the very important role by using this waste material from the industry, which can avoid dumping or landfilling into the environment, which can have the further advantage. We are also further investigating that what are the technical feasibility will be for using the nanosilica, given the cost, and what are the additional property can be developed by using the nanomaterials. Thanks to my team as well as my Sarda professors for helping me to carry out the study. Thank you very much.